Good day and welcome to One-on-One Maths Private Tutors. We continue on O-Level and IGCSE Mathematics for CIMSEC and Cambridge on the topic Statistics. Today we are going to look at cumulative frequency diagrams. A cumulative frequency diagram is a way to display a large set of grouped continuous data. It can be used to estimate the median of the data and to give information about the spread of the data. The table below shows the distribution of heights of 60 plants. The data has been combined in the cumulative frequency table. The cumulative frequency is the total of all the frequencies up to and including the selected group. This is the main point about cumulative frequency diagrams. So to complete the cumulative frequency table, we add another column for the cumulative frequency, CF, cumulative frequency, which is the total of all the frequencies up to and including the selected group. So in this cumulative frequency column, 0 to 10 is 1. To 20, we add 3 and 1, and we get 4. The cumulative frequency up to 30 is 9 plus 3 plus 1, which is 13. The cumulative frequency up to 40 is 25 plus 9 plus 3 plus 1, which is 38. The cumulative frequency up to 50 is 11 plus 25 plus 9 plus 3 plus 1. So to make it easy, just say 38 plus 11, then you get the value there, which is 49. To get the value here, you say 49 plus 6, which is 55. To get the value here, it's 55 plus 3, which is 58. To get the value here, 58 plus 1, which is 59. To get the value here, we say 59 plus 1, which is 60. So we'll find that the final cumulative frequency will be equal to the total, which is 60 there. That's how you can check if you have done the correct additions to get the cumulative frequency column. Now, we also have to add a row for less than or equal to 0. There are no heights which are less or equal to 0. So we can add this row, less than or equal to 0. The frequency is 0 and the cumulative frequency is 0. This is our starting point. So this row is included in the table to show that there are no plants with a height of 0 or less. So at every position, and also on this column, we will only have the upper limit. So when constructing our cumulative frequency table, we'll have to take out the lower limit and only remain with the upper limit, because the cumulative frequency table is the total of all frequencies up to and including the selected group. So we only take the upper limit of the selected group and add all the previous and the current frequencies on that level. Now we can remove this and have our cumulative frequency table like that. So this is our cumulative frequency table, which we will use to draw our cumulative frequency diagram, which is a graph of cumulative frequency against height. So on our horizontal axis, we'll have the height. So we'll label it height in centimeters. Then our vertical axis will be the cumulative frequency. So our height starts from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Then we go to our cumulative frequency. 10, 20, 30, 40, 50, 60, 70. Then we plot. For 0, we have 0. Our first point is 0, 0. Height up to 10, we have 1, which is there. Height up to 20, we have 4, which is here. Height up to 30, we have 13, which is here. Height up to 40, we have 38. 40, 38, which is 2 below 40 here. Height up to 50, we have 49. 50 is here, 50 is here. Height 49, frequency. One small square before 50. Height up to 60, we have 55. So 60 there, 55 is here. Height less or equal to 70 is 58. 70 there, we go up to 58. Height before 80 is 59. 80, 59 there. Height less or equal to 90 is 60 here. So we join these points freehand to make this curve. Remember, use a pencil so that when you make a mistake, you can rub and try again. So this is our cumulative frequency diagram, which is also known as an ogive. So to summarize this, when we are given a frequency distribution table for continuous data, we can create a cumulative frequency table, which will enable us to make a cumulative frequency diagram, also known as an ogive. Let's look at this question. The table shows the distribution of the masses of 100 apples. Make a cumulative frequency table for the data. So we start our table. We have our mass in grams and our cumulative frequency, which we are going to obtain from these frequencies. So our masses start from above 50 up to 300, because so our starting point should be mass less or equal to 50, which is 0, because mass is starting from above 50 to 300. So we take the lower limit of the first group, then that is our starting point. Our next point is the upper limit of the first group. So we say m less than or equal to 100. Those that are less or equal to 100 are 15. Then we take the upper value of the next group. Mass less than or equal to 150 is 18 plus 15, which is equal to 33. So we are accumulating the frequencies. Then we take the upper limit of the next group, which is 200. So for mass less than or equal to 200, all the masses that are less than or equal to 200, which is 34 plus 18 plus 15, which is 67. Then we go to the upper limit of the next group, mass less than or equal to 250. Then we add 25 to 67, or 25 plus 34 plus 18 plus 15, which will give us 92. Then we go to the upper limit of the next and last group, which is 300. And we say mass less than or equal to 300, which is 92 plus 8, or the sum of all these, which will give us 100. So we have done the cumulative frequency table for the data. Now we have to draw the cumulative frequency diagram, or the ogive. So we use our graph paper to draw the cumulative frequency diagram by plotting these points. So on our cumulative frequency diagram, our cumulative frequency is always on the vertical axis. So we have our cumulative frequency there. And on the horizontal axis, we have the other piece of data. So we check out the scale we may use. Our mass is ranging from 50 to 300. So we may have horizontal scale as 0, 100, 200, 300, and 400. For our cumulative frequency, it's starting from 0 to 100. So we may start here 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So this is for the cumulative frequency. For mass 50, which is here, halfway between 0 and 100, we have 50. Our cumulative frequency is 0, which means there are no masses up to and including 50. For our mass of 100, we have 15 apples, 100 and 15 there. So 15 is here, 100 is there where they meet. That's our point. For a mass of 150, we have 33 apples. So 33 apples weigh up to 150 grams. So this is 33 there, 30, 31, 32, 33, coinciding with 150. Up to 200, we have 67 apples. 200 is here. We go up 200 to 67, which is 3 below 70. So 200 is here, 67 is there. And 92 apples weigh up to 250 grams. So we go to 250, which is here, go up to 92. 90 is here, 91, 92. So this is the point we are looking for. 92 is there. Then 300 grams. 100 apples weigh up to 300 grams. 300 grams and 100, which is here. Now the task is to join these points. Freehand, you join the points to obtain a cumulative frequency diagram like this. So we have done that, drawing a cumulative frequency diagram. Estimate the number of apples with a mass of less than 80 grams. So we go to 80. This is 50. 2 squares represent 10. So this is 60, 70, 80. So 80 is here. And we take our straight line up with a ruler to the graph. And where it meets our graph, we draw a horizontal and read off this value, which is 9. One small square is representing 1 unit here on the vertical axis. The number of apples that are less than 80 grams is 9. So here we can say 9. For 2, estimate the number of apples with a mass of greater than 190. So we go to 190. If this is 150, 160, 170, 180, 190 is here. So we take our ruler, draw a vertical from 190 up to the curve, and where it meets the curve, we put a horizontal and then read off this value, and we get 59. Now, this graph tells us that 59 are below 190. We want those above 190. So we will say the total 100 minus 59. Then we get 41. So we are saying an estimate of 41 apples is above 190 grams. So here we can say 41. So that is how we use a cumulative frequency diagram. Thank you.